This conference is brought to you by ColdStack, React and React Native development experts.
Hello everyone, I'm Shivay Lamba, currently a Google Storm Code mentor at MediaPipe and TensorFlow and a developer advocate at Fabric. I'm really excited to be presenting at React Native EUCon 2021, and the topic of my presentation is machine learning with React Native using MediaPipe and TFLite. So we'll be going over what exactly is machine learning and how can we integrate it with React Native and what exactly are MediaPipe and TFLite. So without wasting further time, let's get started. Now, of course, we all know that how incredible machine learning is. Probably each and every different aspect of life that we see, whether it's some kind of an industry, healthcare, medicine, is today utilizing machine learning. And machine learning in mobile devices is something that is gaining a lot of attention today because a lot of the different applications and processes are happening with the help of smartphones and websites. And it becomes imperative to also be able to include machine learning within mobile devices. Now, generally, mobile devices are having lower end processors as compared to, let's say, standard computers and servers. Therefore, there is a need to be able to actually run machine learning models on lower end devices. And that does require you to have specific changes be made to your machine learning models or support for running these machine learning models on these devices. And we can also have on device machine learning for faster processing. So, removing the need to actually connect to a machine learning model that might be hosted on a separate server or on a cloud, which can result in increase in the latency, that can be covered up or that can be reduced by actually introducing the machine learning to take place on the device itself as the processors of the various devices and as the machine learning application and the models themselves are becoming more compact and becoming easier to run by increasing their performance and reducing the overall you could say processing that they actually require. So both of these different techniques is actually helping us out to do a lot of different things like on device translation of languages, on device classification of images, being able to detect different things and do a lot of different on device algorithms that can run machine learning algorithms that can run on mobile devices. And that is making machine learning really you could say accessible on these mobile devices as well. Now, we'll be talking about a few different solutions that are there, and we'll be looking at how can we integrate the two different methods, that is either MediaPipe and TFLite, both for React Native applications. Now, let's take a look at this particular slide and let's see, like, okay, from all these different images, what are all of these different images having something in common? So you see an Android picture with face detection, you see an iPhone XR showing you poses and basically landmarks of your hand, you see the web where you can see the different kind of effects happening on this girl, then we have Raspberry Pi and we have basically the webcams, and all of them are having something in common. And that something in common is that they are all having different applications of machine learning, and that is being powered by one technology. And that technology is MediaPipe. MediaPipe is an open source cross platform framework that is provided by Google that helps to build perception pipelines, or we can also say that they actually help us to build a lot of different audio, visual, and video based pipelines. And it is widely used within Google for a lot of its research and products. And probably till 2018, it was internally used by Google and not really known by a lot of people. But after having been introduced and open sourced in 2019, now it is being widely used to also do a lot of different machine learning implementations and pipelines built around video, audio, and sensor data. So it can be used to basically do data preparation pipelines for machine learning training, or it can also be used for doing ML inference pipelines. We'll be also looking at a lot of different examples on how it is being actually used, and that will give a better perspective of why machine learning using MediaPipe and being able to integrate it is really popular and useful. Now, some of the features that are actually provided with MediaPipe, it first of all helps us to actually include end-to-end acceleration. That means that whatever acceleration is required for the machine learning models to actually work, that is provided by the on-device support that is, there when we are actually implementing MediaPipe on the mobile devices. Now, you just need to build it once and it can be deployed at multiple places. So, if you're creating a MediaPipe based machine learning solution, you don't need to just, it's not just okay that it will be limited to mobile devices. It can also be used for the web, for Python, and for other places as well. So, you just need to create one MediaPipe solution that can be deployed to various places. And these are completely ready to use solutions. There's no requirement to actually write post code for doing things like object detection, face recognition, and the solution itself will be provided to you with the help of the MediaPipe solutions that we are building, and it's completely open source as well. Now, taking a look at some of the popular solutions, you'll see selfie segmentation that allows you to basically run segmentation masks that allows you to recognize the humans and their faces in the current window, and that will help you to basically do things like changing your background that also we see in things like Google Meet or Zoom. Then you have face mesh. Now face mesh basically points out 468 different landmarks on your entire face, and this can be used for a lot of different applications, like let's say putting up makeup, and we'll see a lot of their use cases as well in the coming slides. Then we have hand tracking that basically has 21 different landmarks for tracking different points of your hand. Then we have basically human pose, which has total of 33 different poses that you can basically have to do things like, let's say, exercise monitoring. Then we have hair segmentation that only detects your hair. We have the standard object detection and tracking that can be used to detect certain objects and identify different objects. Then we have face detection. Holistic tracking is basically combining all face mesh, hand tracking, and the pose in OR, right? And you can do a lot of different things with that as well. Let's say create VTubers or, create such kind of animations. Then we can use 3D object detection, also called as Detectron, right? And all of these different solutions are ready-made solutions that have been provided by the MediaPipe Solutions team. And you can just go to mediapipe.dev and look at one of the solutions and look at their implementations for Python, Java, Android, iOS, web, right? And you can start utilizing these solutions. Now, these are some of the examples where, it is being used right now. So for example, you can see the AR lipstick try on, where you can see that it is using the MediaPipe face mesh model to basically detect the lips. And whenever you're putting some kind of an effect, it will be able to actually detect that. Then you can see some of the MediaPipe being utilized within, YouTube itself. And you can see that being utilized in the AR movie trailer that is, being shown over here on YouTube. And you can see being able to detect things, for example, in the lens live living surfaces, then showing augmented faces that again is utilizing the face mesh. And then we have some kind of on-device machine learning capabilities that are happening, let's say with the help of lens translate. All of these are essentially capturing the data that is there on the device itself, and helping to carry out different kinds of machine learning MediaPipe based solutions. And these are of course just a few of the examples, but there are so many different kind of applications that you can build, and that is why MediaPipe is becoming really popular for creating machine learning based solutions applications on mobile based devices, because of its easy integration and really great performance as well. Now, to just sort of, look at, okay, what are the current things that have been released, right? So, of course, before it was released to the public, there was a lot of application of MediaPipe use cases within Google. ever since starting in 2012. It was being used a lot in YouTube whenever there's any kind of a YouTube upload. So the processing in that, and then it is also being used in YouTube Stories. Right now, we actually see it being used in things like Nest Cam, the security cams. We see it in Google Lens, AR ads. We see it even in GCP, and specifically in the Cloud Vision API, Cloud AI videos. So all these are basically different solutions provided by Google, which does internally use MediaPipe, and that is why it makes it so versatile across different platforms and not just being limited to mobile devices. And let's take actually an example of one of the live perceptions. So let's say that, like, what we are trying to get is the hand tracking to actually work with the help of MediaPipe. Now let's see how does this actually work. So let's say that what we need to do is that we have been given an image of a hand, and all the different landmarks, the 22 different landmarks, are represented over there inside of the right hand side. So that is our ideal case, that we want to generate the landmarks and then superimpose them with the live footage or the live video that is being represented right now. So what we can do is that, let's say that this is our perception pipeline. So the first thing that you'll see is basically your video input, which is providing you the live footage of whatever you want to actually track. Then you'll see the next process taking place, which is basically the image transformation, which takes in your video input and converts it into a relevant size that is required by the image processing algorithm. And once it has been resized and scaled to a relevant size, we are basically converting that image into tensors. So since MediaPipe internally uses a TFLite, we are basically going ahead and converting our image that we get from our video input into tensors. Now, if you are not aware of tensors, tensors are essentially these numerical arrays, high dimensional arrays that contain values, and again these can be used for different kinds of calculations. And then from, let's say, any particular given machine learning model, we run the inference on these tensors, and we are able to decode information about the tensors. And then basically what we do is, once we have gotten the information about the tensors, we render basically the landmarks on top of these images, and then we display the resulting video output that showcases the basically this particular the same thing that it renders the landmarks on site on the video that you're showing. So basically that is how the inference of any kind of a MediaPipe based solution takes place, where you give an input and it runs the inference on top of it and poses the landmarks based on whatever it is detecting. And when we're talking about MediaPipe, if we go a bit deeper into how MediaPipe actually works, so you might have heard about the graph data structures, right? It's really common. It's representing various types of edges, vertices, and the flow of information takes place through different edges and vertices. Similarly, in MediaPipe, we have the MediaPipe graph that is sort of laying down the path of how basically the different information about, let's say, the input and the respondent the responding or the relevant output is flowing through that MediaPipe graph. Essentially, we are containing the entire solution. Whenever we're talking about like any kind of a MediaPipe based solution, your input that you're providing, or sorry, the image that you're providing will be given to the MediaPipe graph, and that information will flow. And again, we do have these edges and vertices. Now, specifically these vertices that we have, they contain configuration information about the different aspects about our MediaPipe solution. And these configuration information are essentially, our calculators. Now, of course, we'll be talking a bit about calculators, but of course, the node of the graph is basically showing us, that it's the calculator. And of course, the entire MediaPipe graph is representing the overall flow of how basically the input image is that, or the input information that we are receiving, how we are able to put up the landmarks on top of it and get the resultant output. Now basically any two nodes are connected by a string, which can be represented as, let's say, an edge of a graph. which basically carries the packets, and these packets are actually containing the information about the, let's say, whether it's the input image, the tensors, or let's say it is providing relevant metadata that will be required for further processing, and it will contain the timestamps alongside that data. Now, if we talk about the calculators, right, that are representing the nodes, so they have been written in C++, and they declare basically both the input and the output ports, that what kind of input do they expect when any kind of an input is actually coming to them via the packet, and what once that, like, some kind of processing has been done, like what is the expected output that they will be sending to, let's say, the next node, right? And they basically implement something called as the open process close methods, which basically means that whenever there is an open process happening or an open method, that means that the full graph is currently running. Processes, like, let's say that whenever some kind of an input packets have arrived at the node, they are ready to be processed, and closes that after one entire run has completed, now it's time to actually close the graph. So that is basically the calculator that is representing at each edge, that is responsible for making changes or bringing changes to the input images that are there, and it will help to basically create our process for converting whatever input is into relevant transformations that need to take place. And this becomes part of the calculator. Now, we do also have some inbuilt calculators. We can create our own calculators. There are a lot of different inbuilt calculators that are used for image, audio, video processing, that are, native with TensorFlow and TFLite for the ML inference part. Now, basically, we also have a lot of different calculators for post-processing as well. So those have actually been created. Let's say, for example, for selfie segmentation, we have the selfie segmentation calculator, and you can also actually go ahead and create your own calculators as well. And finally, basically, what we are going to be talking about is the synchronization. And this is really important because all the inputs that we receive inside the calculators and how they're, being processed and they're going outside, we need to make sure that the timestamps are not compromised. If the timestamps are compromised, then it can actually result in erroneous data. And that is why the synchronization is an important aspect of how the MediaPipe solution actually works. And we can also talk about a subgraph. Basically, a subgraph will be used, whenever we are having to divide our steps into multiple steps. And like, you could say that a subgraph is a part of the main graph, and it can also have its own calculators and be used to basically do one of the tasks that will be there. So as you can see over here, that if we have a larger a larger task to take place, we can have one subgraph that is dedicated to, let's say, only the hand landmarks, and then let's say one subgraph only for taking care of the pose landmarks. And of course, the main aspect of this is that the video will be taken in. It will be passed through the hand landmarks, and you'll see the rendered image. But of course, there are certain issues that can take place, because the hand, let's say if you are using a live video, the scale of the hand will change dynamically if, let's say, you're taking your hand closer or taking it further away from the video camera. And then, let's say, it will actually take a lot of capacity from the model to deal with such kind of variations that takes place. So there are steps that we can take place to overcome these issues, or basically these issues in real time. And that is why, like, we can also use a lot of different techniques to optimize our performance of our models as well. And if we just look at an overview of how does the MediaPipe tech stack look like, so at its core, we have described that basically we have created this cross-platform framework that has been written in C++, and it has support for interacting with things like TensorFlow, OpenCV. So it comes in with helper utilities from TFLite that can be utilized, right? And if you look at basically how does the entire functioning work, so at the core level, you have your graphs that are responsible for showing the path of how the packets are flowing in from various, and when how they're being collected at different nodes. Now these nodes are essentially calculators, and apart from all of these, you do get certain APIs that help you in your process. One is the graph construction API, that will be that will be actually helpful for creating a graph for the first time. The calculator API and the graph execution API, all of these different APIs are responsible for helping run your graphs. And essentially at the top layer is all the different kind of applications that are possible to run with, on whether it's the desktop, Android, iOS, or let's say even in embedded devices like IoT core, or let's say for example Raspberry Pi. And this sort of shows you high level overview of how basically the MediaPipe tech stack goes from the top to bottom being at its more raw level. And that is how sort of the MediaPipe applications look like internally. And you can actually go ahead and look at some of the docs if you actually want to go ahead and understand some of the parameters. And if you want to look at some of the examples for MediaPipe, you can go ahead and actually look at that. Or you can also use the visualization tool for MediaPipe that helps you to see, okay, if you were to build a MediaPipe solution, how would it actually look like. Now we can also take an example of some of these, mobile examples where, for example, we have the hand tracking GPU based, where basically the GPU is powering, the MediaPipe hand tracking, and you can see the visualization that has been built for that, and similarly for, the face detection and the object detection. And now talking about TFLite, right? So TensorFlow Lite is an open source framework that is specifically, used for deep learning. Now it comes, or it stems from the main TensorFlow library, and it is used for, on-device inference. So whenever you want to actually go ahead and do your machine learning, and run your machine learning algorithms, doing that inference on device, on your, let's say, mobile devices or edge devices, it is a really great tool to use. And again, it supports for on-device machine learning, and again, it gives a really high performance. So one of the questions that we before move on to is, we have these two different ways, right? One is TFLite and the other is MediaPipe. Now, MediaPipe is generally used mainly for the audio, video, and such kind of streams, because you're receiving these media streams, and these are the ones that are responsible for being sort of shown and then being worked upon. But TFLite allows you to actually convert any kind of a TensorFlow based model into a TFLite format that can be utilized on your device. So of course with TFLite you get much more amount of freedom in terms of what kind of models you actually want to run. Those might not necessarily be just audio or video based. So for example, again, with respect to, let's say, if we were to create like a solution that has been built for the for the mobile based devices, we can use MediaPipe for things like doing pose detection, exercise monitoring, right, audio and video, for, let's say, doing things like facial actions, creating face masks and all. So all that can be done very easily with the help of MediaPipe. But of course, with TFLite, you are open to a wide variety of different kinds of models that you can actually run on your mobile device. So after having converted a model that has been written, let's say, in TensorFlow and Python, you can convert it into a corresponding TFLite format, and that will actually help you to run those on React Native on mobile-based devices. And let's actually go ahead and take an example of TFLite actually being used for doing an image classification problem in React Native. So as you can see from the code, over here in the first, essentially the third line, we're importing the TFLite React Native package. Now this is an npm package that has been created for importing the TFLite, inside of React Native. So we are importing TFLite using the, basically the npm module TFLite React Native. And the idea is that we'll be using the image picker npm module to basically pick any image. And in our React Native application, our machine learning solution will detect what is the class of the image that we are going to be having. So in the line number 5, we are just initiating our TFLite function, or sort of our object, and the method TFLite. And as you can see over here, we have just provided some initial, sort of declarations that are there to basically do things like height image of our canvas, things like what is, the detection model that we're using. So we are specifically using the Coco SSD MobileNet model. Now we also have some other ones as well. We have the YOLO model, we have SSD MobileNet, and these are the some of the models that we'll be actually comparing with. So we are having three different types of models that we're going to be using. Then we are setting up our initial state that contains like the model source, what is the image height, and what are the recognitions. Because when you're going to be running these machine learning models on top of your image, they're going to be providing you an array of recognitions, but the most recognized one will be selected. So that is what is happening in our initial declaration of our variables of important details that are required. Now, let's actually go ahead and look at this particular code where we are going to be looking at all the different kinds of models that are currently being supported. So we have basically taken three different models. The first one is the SSD model, and as you can see, like within these models, we have a unique TFLite, a unique TFLite file for the different models. So the first model is the SSD MobileNet model. We have all the labels. So the labels are essentially what will be recognized whenever you provide any kind of an image. It will actually be able to provide like a label to it based on whichever label it the machine learning model actually thinks is the closest. Then we have the YOLO. Again, YOLO is used for image classification, and we have another TFLite file for it. And then we have a standard MobileNet version v1 that is the TFLite. So we can sort of select one of these models based on the performance that we are seeing using the switch statement. And as you can see that the TFLite dot load model is responsible for actually going ahead and loading the model inside of your local storage, because initially the model will not be loaded directly for saving the time and saving the amount of computation. But using the TFLite.load model, we are basically loading now the desired model. So by selecting okay, which particular model do we actually want to load, we'll be loading that particular model, and that will be used for doing the image classification. Now, if we go ahead and look at the next particular code, now this is the code that is being utilized for rendering the boxes. So, of course, what we want to do is that once we detect something inside of an image, we want to create a bounding box around it. Now, what exactly is a bounding box? A bounding box is representing, four different points, like a rectangle, you could say, and those, are sort of the ending points where we have detected something, inside of the image. So we are going to be using the rendering box function to render basically the bounding box on top of the image that are being recognized. And as you can see, what we're doing is that we are having this recognitions.map because there will be a number of different recognitions. And for all of them, what we're doing is that we are basically going to be, having set the coordinates for our left, top, width, and height. Basically, this will give us, the coordinates or the endpoints of that particular image where we are creating the bounding box. And we're returning a React Native view. That view is basically the generated view that is created when we have detected something successfully and we want to render the you could say the bounding box on top of it. So we are returning a view, a React Native view, where you'll see basically it being created by a blue colored background. As we take in the text style, we have basically also used it, and we are using the styles.box. And what we are returning is basically the detected class. So class of what type of image that is there. So we are detecting that, and we're also giving like what percentage is the confidence, because as we know in machine learning that based on any kind of recognition or predictions that you're making, you'll be getting a range of different predictions, but we are going to be taking the one with the highest prediction, and we'll be returning that and drawing that once we call the render boxes function. Now, if we go ahead and look at the code that is our main code, we are looking currently at the on select image. Now, in this, we use the npm package of image picker, and we go ahead and select one of the images. So you'll be providing the path in your OS, since this is React Native, so we're providing that path, and then you'll be giving the response URI and the file path. We'll be defining the height and the width of the response, and we'll be basically giving in the state, we are using the set state. So since we are using React as well over here, so we are setting the state of the source path file, and what is the image height. Now this is where we are also, like, as you can see, height, we are doing basically, we are going ahead and transforming the height, the image height and image width in the next couple of lines, where we basically are scaling it, right? And then what we're doing is that whatever particular model that we want to actually go ahead and use, we have created the switch statements, and we have created the different cases. Now let's say if we want to use the SSD one, we can simply just go ahead and call the initial method that we had declared, TFLite, and we can use the detect object on image function from it. And in that, we'll be basically passing on the path, the threshold that is that is required, and the number of results per class. And that is where we are then going to be calling, right, the basically this function, and the detect object on image function will go ahead and try to detect if it finds out something. And if it does, right, if there is some error, then it will throw the error. But otherwise, if it does not throw an error, within our current state that we are maintaining for the recognition, we are basically going ahead and with the recognitions that we have, we are providing that resultant array of basically, or you could say the map of the resultants, where basically for each particular different type of result that it gave, it has given a corresponding value attached to it. So it's giving you a map of different recognitions that are made. For example, if an image is of a cat, it might have detected cat, dog, and some other kinds of labels as well, and their corresponding percentage of how much percent, like the model is actually confident that it will be true. And you can see that being utilized for all these different ones. Now whichever one is the one that is having the highest one, that will be, again, as we have discussed, right, will be used in this render boxes one, because from the state we are first finding out, okay, which particular model to use, what is the map of the recognitions and the image height and image width, and this will help us to render the boxes, and this will go ahead and be utilized to draw it on the canvas. So apart from this, the other steps that you'll be doing is basically create another create basically components. One component would be to render the output image that will be there, and on the output image you'll be rendering the bounding box. And of course, if you, let's say, are trying to do it on live via, let's say, your webcam, you can have another component and use the React Native webcam, and have those and sort of create this entire as, let's say, a separate view inside of your React Native application. But this sort of shows an example of how it would function. So you pick an image, you select that image, and you put it, and the machine learning model, or sort of the TFLite model, is actually able to detect multiple objects within a single image, and it will be able to create the corresponding bounding boxes on top of each one of these, and help us to create a simple image classification solution on React Native. Now apart from this, there are a lot of other benefits as well. So there is, of course, the simple example, but of course you can do a lot of different other things by including TF-Lite with React Native. Now the support for specifically running MediaPipe solutions inside of React Native is not that great, but there are a lot of different sort of things happening within the Google's MediaPipe team to help to integrate, because right now there is a great support for running it in native Android and native iOS applications, but very soon we should be able to actually go ahead and get our hands on basically with the implementations of React Native with like implementation of MediaPipe solutions with React Native. So that sort of is basically the example that we sort of covered today. And with that, that brings an end to my to my talk, and I hope that you have liked and you have learned something from this particular talk. The most important things to sort of keep in mind is that MediaPipe is a really great solution that has been created by the Google team, and it has a lot of future applications. And of course, the amount of support and the amount of examples that are coming out for the MediaPipe community, those are really great to see. So if you are genuinely interested in creating these streaming machine learning applications, now it could be something like like a physiotherapist, virtual physiotherapist, let's say, or some kind of a dance teacher, or doing things related to your face, and all these will actually be come in very handy and benefit by the MediaPipe solutions that are actually provided by the MediaPipe team. And you can definitely go ahead and check out those. And of course, TensorFlow is sort of at its core, it allows you to run the TensorFlow models using basically by using a TFLite, or like sort of a light version of the machine learning model. But it's been generally created for running on device machine learning solutions, right? And it's so that it can do the ML processing on device, and that makes it really great. And of course, it's not just for ML solutions, right? Or basically for streaming solutions. It can be used for a lot of different other aspects as well. So with that, that brings an end to my talk. I hope you liked the talk, and you can connect with me on my Twitter handle at the rate howtolap, and on GitHub on github.com/Lamba to ask any questions that you might be having with respect to MediaPipe, how to integrate TFLite with React Native, and how to basically empower React Native applications, because React Native is one of the most popular frameworks that are there. And of course, being able to integrate machine learning models with them is highly useful. So thank you so much for attending this talk, and I hope to see you in next year in person. Thank you so much.